After talking about the transformation equations and the special cases involved, then let's try to introduce the concept of principal plane and the principal stress. Very often we care about the extremum of stress inside the material. For example, the maximum stress, because we care about the impact of stress inside the material and we have to calculate what is the maximum inside such that we can really choose the correct material that we want. An inclined plane with maximum magnitude of direct stress is said to be a principal plane, and the stress is called principal stress. So the principal plane and the principal stress is basically talking about at what angle of inclination you can obtain the maximum stress inside the stress element. To do this, we are going to find the maximum of the stress with respect to theta. Still, recall that we are talking about angle of inclination. Therefore, we are interested to the variation of stresses with respect to theta, the angle of inclination. That is, we try to model our transformation equation as a function of theta. So as what we have learned before, we know that the transformation equation has a lot of variables like the sigma x, sigma y, as well as tau xy. But here we mainly concentrate on theta, the angle of inclination. To find the principal plane or the principal stress, the first step we need to do is to take the derivative. The objective is to find the maximum, so we will take the derivative with respect to theta. Then the sigma x1, the theta, after differentiating this thing, equals to minus sigma x minus sigma y. We wish to solve when the derivative equals to 0. Then this equation will become this. Solving for this equation, we can have 2 tau xy cosine 2 theta p equals to sigma x minus sigma y sine 2 theta p. Then we have tangent 2 theta p equals to 2 tau xy divided by sigma x minus sigma y. However, instead of writing tangent 2 theta p in this term, we divide by 2 in both numerator and the denominator for some reasons. So I will tell you the reason a little bit later. So eventually you will get tangent 2 theta p equals to tau xy divided by sigma x minus sigma y divided by 2. Then, since we are talking about tangent to theta, we can draw this right angle triangle in this way. This angle is 2 theta p. Tangent theta equals to tau xy divided by 1/2 of the difference of the direct stress, sigma x and sigma y. Then, by Pythagoras theorem, we can find R. The reason why we name it to be R will be discussed a little bit later, but at this moment, you just remember, okay, R is a quantity which represents the hypotenuse of this right angle triangle. Next, we want to solve for the stresses. So still recall that we are going to find the principal plane and the principal stress. Therefore, we want to solve for theta and the stresses, okay? However, for tangent to theta p, we can decompose it into sine divided by cosine, right? But for sine divided by cosine, there are two forms that you can write. One is that both of them are positive. Another form is that both of them are negative. So note the difference in symbol. Now let's consider the principal stress, which is the direct stress sigma x1 theta. Transformation equation says this. Now let's consider this equation. So the reason why we write tangent 2 theta into sine 2 theta divided by cosine 2 theta, the reason behind is that in the transformation equation we only have sine 2 theta and cosine 2 theta. So by writing tangent 2 theta in this way, we can do the direct substitution into the equation. Anyway, substitute the two groups of possible values, cosine 2 theta and the sine 2 theta, into the transformation equation. First, we substitute the first system into the transformation equation. Then the first principal stress is given by 1/2 of sigma x plus sigma y plus sigma x minus sigma y divided by 2 times cosine 2 theta, which is sigma x minus sigma y divided by 2r. Then the whole term becomes this thing, okay? it is not the end. Next, we substitute sine 2 theta into the equation, which is tau xy divided by r, and then you times with the tau xy located here. Then this term will become tau xy squared divided by r. We further simplify this expression by grouping those two terms with the same denominator. Then you can have this expression. Finally, we take 4 from this term, okay? We take 4 out, such that it can be cancelled with the denominator. Then the thing left in this bracket will be something like this. However, still, what is r? Just now we said r equals to square root of sigma x minus sigma y divided by 2 squared plus tau xy squared, okay? But you can see here there is no square root, so this term will automatically become r squared. And here the r squared is cancelled with r, then this term will become r. Therefore, sigma 1 equals to sigma x plus sigma y divided by 2 plus r. And you know r is just something like this, a square root. So there is another principal stress which is similar. You are going to substitute this system into the transformation equation. Then everything are the same except the symbol become negative. Then we group those two terms behind. Then this will be negative. All the rest of things are still the same. By the similar procedures, you can make the numerator to be 4r squared, cancelled with the denominator 4r. Eventually, you will get minus r behind. Therefore, the second principal stress is given by sigma 2 equals to the average of the rest stresses minus r.